Hey guys, let's take a look at sketching this graph and then stating the end behavior. Now, I don't see stating end behavior as often with quadratics, but we can look at it here. It was a question asked this week by a learner, and so it's a good question. The box right here shows you sort of how the notation usually looks. You might see it written in other ways, but a lot of times it's written this way, and these blanks are what you would fill in depending on what is happening in the graph. So know that when you see this, it's saying as x approaches negative infinity, y approaches what? In other words, as x is going to the negative infinity side, what is y doing? And then as x is approaching the positive infinity side, what is y doing then? So let's sketch the graph and then we can start to think about the end behavior. So this is almost the parent function, y equals x squared, which is just a regular parabola at 0, 0, opening upward. The only difference is that there's a negative, so it's going to open downward. So technically, this is, you could say that this is in vertex form. Vertex form means that this is saying this. Now, think about why it doesn't have all of that extra in it. The negative is there, x minus 0. Well, that's because the form a times x minus h squared plus k. So if you've got the formula sheet, you'll see that vertex form there. But we don't say x minus 0 if it's 0, right? Just like you don't say you're 16 plus 0 years old. We don't say that. You say you're 16 years old or whatever. So yeah. You don't put the minus 0 in the final part. And then plus 0 is the same idea. You don't add 0 to things because it's understood. If you add 0, it doesn't change it. It's not any different. So all of that to say that the vertex here is still 0, 0. There's the 0 and there's the other 0. So the vertex is 0, 0 for this function. Now, if I want to get some points on either side, you can think of it as a t-table. You can think of it as just plugging in some x values. So y equals negative x squared. Let's get at 2. Let's see what that's going to be. So y equals negative x squared. For x, I'm going to plug in a 2. I'm going to see what the point is at 2. So 2 squared is 4, and there's still a negative in front of it. So that's just negative 4. So at 2, we're down 4. And remember, this is always going to be symmetric. And so if that's 2 to the right, I'm going to go 2 to the left, and it'll be down 4. So I can just plot a point that's going to be corresponding. Okay, so that gives me a good idea, enough to kind of get a sketch here of what's happening. And I knew it would just be sort of a basic parabola, but opening downward, right? Okay. You could have chosen 1, 3, 4, whatever, I mean, at 3, even though it's going to go off because it would be at -9. So it would be, maybe down here. 4 is going to be at -16. So we'll just continue. All right. Let's think about end behavior. So x, as x approaches negative infinity. Well, you know that the negatives are in this direction on the x-axis and the positives are in this direction. So as x goes this way, what are the y values doing? And we see that we've got an arrow saying the y values are just going to continue to decrease and go farther into the negatives of the y-axis. So we would say that y is going to approach negative infinity. You would either say negative or positive infinity. And as x approaches positive infinity, so now let's change the color. As x is going in this direction towards more positive and greater positive numbers, what is the y value doing? Well, it's continuing to drop down, it's continuing to fall, and that is in the negative direction. So this is still going to negative infinity. So as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y still approaches negative infinity because both sides are opening downward in this U shape. All right. That's in behavior. I hope that helps. I'll see you next time.